We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Very good morning, good afternoon, good night, whenever you watch this video. So, in my previous video for properties of steam, I have explained about different types of calorimeters like a barrel calorimeter, separating calorimeter, throttling calorimeter, and today we will understand a new calorimeter which would be the last calorimeter of your syllabus. Now the last calorimeter is combined separating and throttling calorimeter. Now if you have watched my video for properties of steam 04 and 05, then this video would be very much easy for you, because in my video 04 properties of steam I have explained the working of separating calorimeter, and in properties of steam 05 video I have explained the working principle of throttling calorimeter. So simply both of the calorimeters now you will combine, because name is what? Combine. Combine means combination of both of this calorimeter. So same working principle. Simply first of all you will write down the working principle of separating calorimeter, then you will write down the working principle of throttling calorimeter. Then how you will connect both of this calorimeter in working principle, that we will discuss today. So now I will start with this video, which is combined separating and throttling calorimeter. Now over here, first of all, what we will do, what is the application of this calorimeter? As you know, any calorimeter is used for what purpose? To measure the dryness fraction value of the steam. Same way that combined separating and throttling calorimeter is also used to measure the dryness fraction value of the steam. That means with the help of this calorimeter, we will find out the value of X for the steam. X means how much amount of water and how much amount of vapor particles are present in a given steam. That X will indicate. As for example, supposing one more time I will say, supposing X is 70%. So what does it mean? That in a given steam, vapor particles are 70% and remaining 30% are water particles. That is the meaning of dryness fraction. Dryness fraction will indicate what? How much amount of water and how much amount of vapor particles are present in a given steam. Now we start with the construction. So construction is simple. That combined separating calorimeter and combined separating and throttling calorimeter. So first of all, over here, as you know, one cup we have drawn in separating calorimeter, which is perforated. Perforated means what? Certain holes are there. Now that will construct one separating calorimeter. So that is your separating calorimeter, which is connected with what? As you know, which is connected with water level indicator. So that is your water level indicator. Some markings are there which will measure the mass of the water, or you can say which will indicate the level of the water. So that is your water level indicator. Now after that, what we will do, that is connected with what? That separating calorimeter is connected with what? That is connected with, over here, barrel calorimeter. That is connected with barrel calorimeter. Now in barrel calorimeter, what's happened? Whatever separated steam is there, that will insert inside of the barrel calorimeter, and barrel calorimeter is located on one weighing platform. So that barrel calorimeter will give the mass of the steam. That you know very well. After that, what we have done over here, we will take one sampling pipe, that you know very well. And that sampling pipe is inserted inside of the main pipe, that also you know. And sampling pipe is perforated at its first end. Why? Because due to the high pressure of the steam in the main pipe, there may be a chance that first end of the sampling pipe may be cracked. So to avoid the cracking of first end of sampling pipe, it is perforated at its first end. Now that much thing you know very well for separating calorimeter. Now in separating calorimeter, what's happened? Whatever steam will come in sampling pipe, that steam will be imparted on this cup. So over here we are imparting this steam on this perforated cup. So due to that, what's happened? In a steam, two things are present that you know. Which one? Water and vapor particles. So water has different density, liquid has, vapor has different, water has different density, vapor has different density. So due to the density difference of water and vapor, what's happened? Both of the particles are separated. One example I have discussed in my previous video. Which one? Supposing you have two balloons. First balloon is filled with water, another balloon is filled with air. And if you hold both of the balloons together and if you will strike both of the balloons on the wall, so which balloon will come earlier? But obvious, water balloon will come earlier. Why? Because density of water is higher than the density of air. That means due to the density difference, what's happened? Water balloon will come towards you, but air balloon will remain over near to the wall. That is due to the density difference, water and vapors are separated. Same way, when steam is imparted on the perforated cup, so in a steam, whatever water and vapor particles are there, both will be separated. They will be separated in such a way that liquid particles will be collected inside of the separating calorimeter, so that separating calorimeter is connected with what? Connected with water level indicator, which will indicate the level of the water. That means with the help of this we can find out the mass of the water. We will find out the mass of the water, and after that remaining whatever separated steam is there, that steam will enter into a barrel calorimeter, and barrel calorimeter is located on one platform which is known as weighing platform, which will measure the mass of the steam. So which will measure the mass of the steam. So if you want to find out the dryness fraction value with the help of separating calorimeter, so X is equals to what? It is MS divided by MS plus MW. That equation you know very well. Okay. After that, that is known as separating calorimeter. Why? Because in this calorimeter, first of all, that water and vapor particles are separated. Then separated water particles are measured with the help of a water level indicator or with the help of separating calorimeter, and separated vapor particles are measured with the help of barrel calorimeter. So that is your mass of steam. So the dryness fraction, if you want to calculate, then this equation will be X equals to MS divided by MS plus MW. Now, one more thing, that for the throttling calorimeter, what we have done, this type of figure we have drawn. Over here one throttling valve is there. Over here I will write throttling valve. In throttling valve, what's happened? Throttling process is taken place. So over here, which steam we are entering? We are entering wet steam. That is the limitation. That throttling calorimeter is useful only for those wet steams which are able to convert into a superheated steam. So over here you will get the superheated steam. Why? Because over here throttling process is taken place. For throttling process, which equation we have written? We have written H1 is equals to H2. So over here your inlet and over here your outlet. So over here enthalpy will be H1 and over here enthalpy will be H2. Now enthalpy for wet steam is what? It is simply HF plus X HFG, which is equals to enthalpy for superheated steam is what? That is your Hg plus CPS, T superheated minus T saturated. Now if you want to know about this equation, then you should watch my video of properties of steam 01. In that video I have explained each and every equations, that for superheated steam why this equation, for wet steam why that equation, for saturated steam why it is HF like this. Right now you should accept HF plus XHFG. So with the help of a throttling calorimeter, you are getting the dryness fraction value, this. So that will be what? That answer will be what? That will be your, if I want to make equation representative as X, so how I can make? I can write X is equals to that term Hg plus CPS, T superheated minus T saturated, minus of this over here. So you HF whole divided by what? Whole divided by HFG. Now limitation of this calorimeter is what? That with the help of this calorimeter, throttling calorimeter, we can find the approximate value, not the exact value. Over here also, with the help of separating calorimeter, we can find the approximate value, not the exact value. Why? Because complete separation of water and vapor particles are not present. That means with vapor particles, over here vapor particles are separated. So with vapor particles, can I say some water particles are also present? That means in barrel calorimeter, which thing will go? In barrel calorimeter, with vapor particles, some water particle will also go in barrel calorimeter. That means in barrel calorimeter, mixture of water and vapor particles are present, and mixture of water vapor particles are known as which steam? It is known as wet steam. Clear about that? Limitation of this calorimeter was what you just tell me, that complete separation of water and vapor particles are not possible. That means with some vapor, some liquid particles are also present. That means in barrel calorimeter, liquid plus vapor particle insert, and liquid plus vapor particle is known as which steam? Is known as wet steam. That means in barrel calorimeter, wet steam will enter. Clear about this? Now, limitation of this calorimeter was what? That throttling calorimeter is useful only for those wet steam which are able to convert into a superheated steam. That means in throttling calorimeter, you must insert the wet steam. Then only you will get the answer. Suppose over here saturated steam is there, then that calorimeter is useless. Superheated steam is there, then also this calorimeter is useless. So which steam is required? Wet steam is required inside of the throttling valve. So what we will do, over here wet steam is there. That is the limitation of this calorimeter, so that approximate answer we are getting. Now that limitation we will convert into advantage. How? Because that wet steam I will supply over here. That wet steam I will supply over here. And limitation of this calorimeter was what? It is applicable for wet steam. So that limitation we will convert in advantage. How? Because over here wet steam is entering in barrel calorimeter. So that steam we will insert over here. Or you can say that wet steam will enter into what? That wet steam will enter into barrel calorimeter, so that it will provide the mass of steam. Now what we will do, that over here, which thing is present? That wet steam is present. Because over here water and vapor particles are present, because complete separation of water and vapor particles are not possible. So what I will do, I will take over here, I will rub the figure a little bit. Over here I will take one outlet, and that outlet I will connect with what? I will connect with throttling calorimeter. So over here which steam will go? Wet steam will go, and that wet steam from separating calorimeter will enter into a throttling calorimeter, that is whole throttling calorimeter. So that what we will do, that with the help of separating calorimeter we will find out the dryness fraction value of the steam. How? Mass of steam is given by barrel calorimeter, and mass of water is given by separating calorimeter. But that is your approximate value. Why? Of dryness fraction? Because mass of steam is not exact, because with some steam, some water particles are also present. So that is why it is not the exact value. That is why dryness fraction value is not correct, or you can say it is an approximate value. So supposing we will say that x1 dryness fraction value, which is measured with the help of a separating calorimeter, is x1. After that, whatever wet steam is there. Why wet steam? Because complete separation of water and vapor particles are not present. So with vapor particles, some water particles are also present. So over here, mixture of water and vapor particles are there, and mixture of water and vapor particle is known as your wet steam. Now that wet steam you will enter inside of the throttling calorimeter. So inside of the throttling calorimeter, what's happened? Throttling process is taken place. That means for throttling process, steady flow energy equation was what? Enthalpy before throttling. Enthalpy, H means enthalpy. Enthalpy before throttling process is exactly equals to enthalpy after throttling process. That means we are writing H1 equals to H2. Now H1 is what? For wet steam, it is HF plus XHFG. And for superheated steam, enthalpy is what? Hg plus CPS, T superheated minus T saturated. If you want to write mass of steam, Cp of steam, then also you can write, and value of Cp you should consider as 2.1 kilojoule per kg Kelvin. Now I will make X as a subject. So this is the equation. With the help of this equation, we can find out the dryness fraction value of this steam with the help of throttling calorimeter. Now over here I will say that X is X2. Why X2? Because X1 we are measuring. Dryness fraction we are measuring with the help of separating calorimeter, which is X1. X2 means what? Dryness fraction value we are measuring with the help of throttling calorimeter, which is your X2. Now if you want to find out the answer of X, so answer of X you can find X1 plus X2 if you will write, so it will be incorrect. Why it will be incorrect? Suppose if you will write X1 plus X2, suppose dryness fraction value is 0.6 with the help of separating calorimeter, X1 value. and plus x2 value, suppose over here dryness fraction value of the steam is suppose 0.5, suppose. So total dryness fraction will be how much? 1.1. And as you know, if you have seen my video number 1 for properties of steam 01, so I will explain one thing, that dryness fraction value never be greater than 1. So over here we are getting dryness fraction value as greater than 1, so which is incorrect. So that is why instead of x1 plus x2, you will write x1 into x2. So that equation you have to remember. Which one? If you want to find out the dryness fraction value of a steam with the help of combined separating and throttling calorimeter, at that time we will use this equation. Dryness fraction value is equals to x1, means dryness fraction value which is measured with the help of separating calorimeter, into x2, means dryness fraction value which is measured with the help of throttling calorimeter. So with the help of x1 into x2 you can find out the answer. X1 answer you will get over here, x2 answer you will get from here. So both of the answers you will insert in this equation, so you will get the final dryness fraction value of the steam. Now that calorimeter will provide the exact value, or you can say accurate values. Why? Because whatever limitations are there for separating calorimeter, that is used as advantage. Complete separation is not possible of water and vapor. That means a wet steam is there, that we will take the advantage, that okay, doesn't matter, wet steam is there, so that wet steam we will insert in throttling calorimeter. What was the disadvantage? That it is applicable for wet steam, so we will make it as an advantage that from the separating calorimeter wet steam is coming, and that same wet steam we will enter in throttling calorimeter. So in short, you have to remember these two equations. Which one? X1 is this and X2 is that. Final answer x1 into x2, so that you will get the accurate value. Now I would like to end this video because I have completed the working principle of combined separating and throttling calorimeter. Now I would like to make a video on numericals based on this combined and separating throttling calorimeters, which are important regarding to your examination. So till then, read hard, work hard. Thank you very much.